Somewhere out past the edge of what your telescope could ever show you, there is a planet that scientists genuinely did not believe could exist. Not unusual, not rare, impossible. According to everything astronomers thought they understood about how planets survive, this world shouldn't be there. It shouldn't have a shape. It shouldn't have an atmosphere. And it definitely shouldn't be orbiting the thing it's orbiting. But it is. And when NASA's James Webb Space Telescope pointed at it, the readings that came back didn't just surprise the research team, they short-circuited decades of planetary science in a single data set. So today, we're going to break down exactly what NASA found, why it has scientists using words like stunned instead of excited, and why this single planet might be the tip of something far bigger happening across the galaxy right now in 2026, while most people are still scrolling past the headline. Here's how this story actually starts. For years, if you asked someone to picture the strangest planet in the universe, they'd probably describe something huge and gassy, or maybe a lonely rogue world with no star at all, just drifting through the dark. That's the image science fiction gave us. But what NASA's Webb telescope actually detected is stranger than anything a screenwriter would have pitched, because fiction at least has to be internally consistent. This planet isn't. According to the research team behind the discovery, this world is orbiting the corpse of a star. Not a young star, not a dying star. A star that already died, violently, and left behind something called a pulsar. Now let's slow down right there, because that word is doing a lot of heavy lifting. A pulsar is what's left after a massive star runs out of fuel and collapses in on itself in a supernova. What remains is a neutron star, an object roughly the size of a city, but packing more mass than our entire sun into that tiny footprint. If you tried to scoop out a single teaspoon of neutron star material, it would weigh more than a mountain here on Earth. Pulsars spin unbelievably fast, some completing hundreds of rotations every second, and they blast out beams of radiation like a cosmic lighthouse sweeping the galaxy. This is not a place where life or comfort or anything gentle is supposed to survive. This is the wreckage zone left behind after a star's death. And sitting in that wreckage zone, astronomers found a planet. Its name is PSR J23222650b. NASA scientists first announced the finding right around New Year's, and by the time follow-up observations from Webb came through in the weeks after, the picture had only gotten stranger. This is a Jupiter-mass planet, meaning it's roughly the size and heft of the largest planet in our own solar system, and it completes a full orbit around its dead star host in under 8 hours. Let that sink in for a second. Mercury, the closest planet to our own sun, the planet so scorched and airless that nothing could ever live there, takes 88 days to make one trip around the sun. This alien world does it in less time than it takes most of us to get a full night's sleep. It's lapping its star nearly 3 times a day, all while sitting in the radiation blast zone of a stellar corpse that should be tearing any nearby planet apart, atom by atom. And here's where it stops being simply unusual and starts being genuinely disturbing to the people who study this for a living. The pulsar isn't just yanking this planet into an absurdly tight orbit, it's physically reshaping it. According to the findings published by the research team, the gravitational pull from the neutron star is so extreme, so lopsided, that it has stretched this Jupiter-mass world into a lemon shape, not round, not the smooth sphere every diagram and every science textbook trained you to expect. Distorted, pulled at both ends like dough caught between 2 hands, locked permanently into an elongated, almost fruit-like silhouette because the tidal forces acting on it never let up, not even for a second. This isn't temporary damage. This is the planet's permanent shape now, forever, for as long as it exists. Now here's a question worth sitting with before we go any further. If this planet is being crushed and twisted by forces this extreme, how is it still there at all? How does anything survive the death of its own star, let alone continue orbiting the wreckage as though, if nothing happened? That question is exactly what sent NASA researchers back to their models. And it's exactly why this single discovery has quietly become one of the most talked about exoplanet stories of 2026 inside the astronomy community, even if most casual space coverage hasn't caught up yet. Because we haven't even gotten to the part that actually stunned scientists. We haven't talked about what this planet is made of, what might be sitting at its core, or why researchers are now saying openly that they don't have a working theory for how a world like this could have formed in the first place. That's next. And once you hear it, you'll understand why NASA isn't calling this just another exoplanet. They're calling it a problem their entire field doesn't know how to solve yet. So let's pick up exactly where we left off, because this is where PSR J23222650b stops being just another strange dot on a star chart and starts becoming something that genuinely rattled the people studying it We know this planet is Jupiter-sized. We know it's been twisted into a lemon shape by the crushing gravity of the dead star it orbits. We know it laps that star nearly 3 times a day while sitting inside a radiation field that should be stripping any atmosphere apart within moments. Now here's the part most casual coverage skips right past: what NASA's Webb telescope actually found inside this planet's atmosphere. According to the research, this world has a bizarre carbon-rich atmosphere filled with soot clouds, and scientists believe its core may have compressed into diamond. Sit with that for a second, because it's easy to let a detail like that fly by without registering how strange it actually is. Not water vapor clouds, like the ones drifting over your head right now. Soot, dark, choking carbon-based particulates blotting out whatever faint light manages to reach the surface of this planet. And beneath that suffocating shroud, under pressures scientists are still struggling to model accurately, the carbon content may have been compressed so intensely that it formed actual diamond at the planet's core. Not as a metaphor for how special or rare this planet is, structurally. A world that may quite literally have a diamond heart sealed beneath a poisoned sky, orbiting the corpse of an exploded star in under 8 hours, warped into the shape of a lemon by forces that would destroy any human-built structure in a fraction of a second. And here's why that detail matters so much to the scientific community, beyond just being a wild headline. According to statements from the astronomers involved, this isn't simple curiosity. This is genuine bewilderment, because no existing theory of planetary formation explains how a world like this could exist at all. Planets, according to the models astronomers have relied on for roughly 3 decades, are supposed to form gently, calm, rotating disks of gas and dust, swirling around a young, stable star, slowly clumping together over millions of years into something round, something ordinary. That process does not include surviving a supernova. It does not include a parent star collapsing into a hyperactive neutron corpse and continuing to orbit the wreckage as though nothing happened. So researchers are currently stuck choosing between 2 explanations, and both of them sound like they belong in a science fiction script rather than a peer-reviewed paper. Either this planet somehow formed after the star's death, condensing out of the chaotic debris left behind by the supernova through a process scientists don't yet fully understand, or it formed before the explosion, as a normal planet around a normal star, and then somehow survived an event violent enough to have vaporized it. Right now, nobody studying this planet can say with confidence which explanation is correct. And that uncertainty, an open, unresolved question sitting at the center of an active NASA-backed discovery, is exactly what should make you pay closer attention. Because when serious researchers admit we don't know in a field this advanced, that's not a small thing. That's a crack in the foundation. Here's the part that turns this from one weird planet into a much bigger story. PSR J23222650b is not an isolated oddity sitting alone in the data. It's the most extreme entry in a growing list of discoveries that have been surfacing throughout 2025 and into 2026, each one chipping away at assumptions astronomers considered settled for decades. And once you start connecting them, the pattern gets hard to ignore. Take what Hubble found just a few months later. Astronomers working with the Hubble Space Telescope identified an enormous planet-forming disk, nicknamed Dracula's Civito, located roughly 1,000 light-years away, officially cataloged as IRAS 23077+6707, and it is unlike anything ever documented before. The structure is turbulent and oddly lopsided, with towering filaments visible on only one side, a planetary nursery that simply shouldn't look the way it looks, according to every prior model of how planets are supposed to form inside orderly, symmetrical disks. The disk itself is almost unfathomably massive, stretching nearly 400 billion miles across, roughly 40 times wider than our own solar system out to the Kuiper Belt. The lead researcher on that discovery, Christina Monch, said plainly that right now we have more questions than answers. Read that again. That's not one scientist stumbling on one strange object in isolation. That's a second one of the galaxy's most trusted instruments, returning data that refuses to fit the boxes astronomers built for it, arriving within months of the lemon-shaped diamond planet. And once you start looking, you'll find this isn't a coincidence limited to just 2 discoveries. It's a pattern stretching across nearly every corner of exoplanet science being published right now, in real time, in 2026. There's a planet with oceans of molten rock. There's a gas giant with weather made of stone. There's a world that might be a second Earth, sitting quietly in data NASA already had sitting in storage for years. And every single one of them is forcing scientists to admit, in published research, that the rulebook they've relied on for understanding how planets are born, how they survive, and how they die, has a hole in it big enough to swallow a Jupiter-sized world whole. That's exactly where we're headed next. Let's keep pulling this thread, because the weirdness doesn't stop at a lopsided planet nursery 1,000 light years away. It gets closer, almost uncomfortably close when you consider it in cosmic terms. In May 2026, a team led out of Oxford University identified something that had never been formally classified in the entire history of exoplanet science, an entirely new category of planet. The world is called L9859d, and it sits just 35 light years from Earth, practically next door by galactic standards. According to the study, published in Nature Astronomy, this is a molten, sulfur-rich world with a vast global magma ocean that likely reeks of rotten eggs. Not rocky, not gaseous, not water-rich. Those are the three categories astronomers have used for decades to sort nearly every planet ever discovered. This is something else entirely, a scorched, sulfurous world with oceans made not of water, but of liquid rock, chemically distinct from anything ever catalogued before it. The lead author, Dr. Harrison Nichols, said it plainly. The categories astronomers currently use to describe small planets may simply be too simple. Think about what that actually means for a scientific field that has spent decades building confident, tidy classification systems, the kind you'd find in any astronomy textbook. If the sorting system itself is flawed, then every planet already placed inside it may need to be reconsidered. That's not a minor footnote, that's the foundation, shifting under an entire discipline. And here's where it gets even stranger, because the weirdness isn't limited to dramatic extremes like lemon-shaped diamond planets or sulfur oceans that smell like rotten eggs. It's showing up in planets that sound almost mundane, right up until you look closer. Take WASP 94AB, a giant planet nearly 700 light years away. In late May 2026, astronomers using Webb discovered that this world experiences something no planet has ever been documented doing before: a full daily weather cycle involving clouds made not of water, but of vaporized rock. According to the published findings, clouds build overnight as air flows across the planet's dark side, swelling into a thick blanket by daybreak, and then, remarkably, dissipating on the sunlit side, leaving clear skies by early evening. A planet with a literal morning to evening mineral weather forecast. Rock clouds gathering overnight, burning away by sunset, on a repeating daily rhythm, eerily similar to Earth's own atmospheric cycles, except built entirely from stone instead of water vapor. And then, almost as if the universe wanted to offer one moment of relief before the picture got even more complicated, scientists found something that felt, briefly, comforting. A giant planet roughly the size of Saturn, more than 330 light years from Earth, called TOI 199b. Unlike the twisted, sulfurous, soot-choked world surrounding it in recent headlines, this one showed something startlingly familiar. Surprisingly Earth-like temperatures and an atmosphere packed with methane. Announced by a Penn State and JPL-led team in May 2026, this discovery briefly looked like a moment of normalcy in an increasingly abnormal year of exoplanet science. But here's the twist inside the twist. This is one of the first temperate gas giants ever studied in this kind of atmospheric detail, meaning scientists genuinely don't know yet whether it's a freak exception or the first confirmed member of an entirely new, unstudied category of world quietly waiting to be found across the galaxy. Lead researcher Renyu Hu put it directly. The goal now is to determine whether this planet is unique or whether there are shared characteristics defining an entirely new type of world. Now step back and look at the shape of what's actually happening here, because no single discovery tells the whole story. It's the pattern connecting them that should hold your attention. A planet twisted into a lemon shape around the corpse of an exploded star. A planetary nursery so massive and lopsided it breaks the models for how nurseries are supposed to look. A newly discovered category of molten, sulfur-drenched worlds that doesn't fit any classification system built before this year. A gas giant with a literal daily rock weather forecast. A temperate world that might be a miracle or might be the first of many. This isn't a handful of unrelated headlines loosely stitched together. This is what happens when humanity's most advanced observational technology, Webb, Hubble, and TESS, finally becomes powerful enough to look closely enough, long enough, at enough targets to reveal something uncomfortable. Our theories about how planets form, survive, and behave were built on an incomplete, almost embarrassingly narrow sample size. And that sample size is expanding faster than the theories can keep up with it. And it isn't just human astronomers squinting at data feeds anymore, quietly filtering through signals one star at a time. A powerful new AI tool, deployed on NASA's exoplanet data throughout 2025 and 2026, has already confirmed dozens of new exoplanets, while flagging thousands more promising candidates, doing the sifting at a scale and speed no human research team could ever match on their own. And what these tools are finding challenges the numbers themselves. Recent research has produced the first precise measurement of a strange gap in planetary distribution known as the Neptunian Desert, a region where close-in, Neptune-sized planets appear around only a tiny fraction of Sun-like stars, far rarer than anyone expected. Ask yourself what that means. It means the galaxy isn't randomly scattering planets everywhere with equal probability. There are deserts. There are anomalies. There are pockets where planets simply should not form at all. And yet, somewhere inside those very deserts, in those very impossible zones, worlds like the lemon-shaped diamond planet keep turning up anyway. So, if the galaxy has rules about where planets can and can't exist, and this planet is breaking them anyway, what does that tell us about how much we still don't know? That question gets even more unsettling once you realize some of the strangest discoveries of 2026 haven't come from distant, exotic star systems at all. Some of them have come from data NASA already had, sitting quietly in storage for years. And that's exactly where we're headed next. Here's something that should genuinely change how you think about space exploration. Not every strange planet discovery starts with a brand new telescope pointed at a brand new patch of sky. Some of the most unsettling finds of the past year have come from old data that had been sitting untouched for years, just waiting for someone to look again. A planet candidate called HD 137010b was found not through some cutting-edge new instrument, but buried inside archived data from NASA's Kepler Space Telescope, which was retired all the way back in 2018. According to NASA's own release earlier this year, this possible rocky world is slightly larger than Earth, orbiting a sun-like star roughly 146 light-years away, with an orbital period close to a single Earth year, and it might fall just within the outer edge of its star's habitable zone, the distance from a star where liquid water could theoretically exist on a planet's surface. The signal had been sitting inside old K2 mission data, flagged years earlier by citizen scientists on public astronomy forums, and simply never followed up on until now. Think about what that actually means. A potentially habitable Earth-sized world may have been hiding in plain sight, inside data humanity already possessed for years, while astronomers were busy chasing new targets across the sky. Alexander Venner, the researcher who led the rediscovery, admitted it himself. It was, in his own words, a product of luck and circumstance. Not a targeted search, not a grand new mission. Luck. Luck uncovered a possible second Earth sitting quietly in an archive nobody had gotten around to double-checking, and that should make anyone pause before assuming we've mapped the strangeness of our universe with any real completeness. If a potentially habitable world can sit unnoticed in old, publicly available data for years, what else is sitting in the archives right now, unflagged, unexamined, simply waiting for the right eyes or the right AI system to finally notice it? And this isn't a one-off. Just this month, in fact, on July the 1st, 2026, NASA's TESS mission announced its own version of this exact story. Using 8 years of archived observations, researchers identified a planet called Gaia 23 Bra B through an entirely new detection method for that mission, a technique called gravitational microlensing, where the gravity of a foreground star bends and magnifies the light of a background star, and any planets orbiting that foreground star leave a tiny detectable signature in that bent light. This particular world turned out to be a super Jupiter, roughly 1.5 times the mass of Jupiter, orbiting an orange dwarf star at a distance similar to Jupiter's own orbit around our sun. University of New Mexico professor Diana Dragomir put it simply, when TESS launched, nobody expected it to ever be capable of finding this kind of planet. And now that it has, researchers believe there are probably other microlensing planets hiding inside TESS's archive that nobody had previously thought to look for. Again, the same pattern. The universe isn't just hiding strange worlds in places too distant to reach right now. It's hiding them inside our own filing cabinets and data we already collected years ago and thought we'd finished analyzing. So let's bring it all the way back to the planet that started this entire story. PSR J232222650b, twisted into a lemon shape, choked in soot, possibly hiding a diamond at its core, orbiting the violent spinning remains of a dead star. In under 8 hours, a planet that, according to every model astronomers had before this discovery, theoretically shouldn't have survived long enough to be found, let alone continue existing under the extreme conditions surrounding it. This isn't just the strangest planet in the universe. It's a piece of trivia to impress your friends with. It's a signal, almost a warning flare, that the categories, timelines, and formation models astronomers have relied on for decades are far less complete than the confident diagrams in any textbook would have you believe. Every impossible planet found over the past year didn't just add one more entry to a catalog. It quietly forced scientists to admit in published, peer-reviewed research that they don't fully understand the rules governing how, where, and why planets exist at all. And here's the honest, uncomfortable truth. This story ends on not a clean answer, an open one. If a Jupiter-mass world can survive being violently warped into a lemon shape around a pulsar, what other impossible configurations are quietly orbiting? Stellar remnants across the galaxy right now, completely undetected, simply because nobody has pointed the right instrument at the right coordinates yet? If an entirely new category of molten, sulfur-drenched planet can exist just 35 light years away, practically next door in cosmic terms, what other categories, entirely unimagined by current science, are waiting in data we've already collected, or in starlight still traveling toward Earth from stars we haven't studied closely enough yet? And if a potentially habitable Earth-sized world can sit quietly inside archived Kepler data for years, unnoticed by everyone except a handful of dedicated citizen scientists, scrolling through old forum threads, what does that say about how much we've actually seen versus how much we simply haven't looked at hard enough yet? Nobody currently studying PSR JA2322265b claims to have a complete explanation for how it formed, how it survived this long, or what it will eventually become. As the pulsar's radiation continues eroding its atmosphere over cosmic time, the soot clouds may thin, the lemon shape may stretch further, or eventually tear apart entirely. The possible diamond core may be confirmed, or it may turn out to be something even stranger that our current instruments simply aren't sensitive enough to detect yet. Every answer scientists have produced so far has only generated new questions layered on top of the old ones. And with next-generation telescopes and AI-driven search tools only just beginning to scale up their reach across the sky, there's no reasonable argument left that this is the last impossible planet we'll find. It's almost certainly just the most recent one confirmed. So here's the question I'll leave you with. Somewhere out there right now in data already sitting on a server, or in starlight already crossing the galaxy toward Earth, something even stranger is waiting to be found. The only real question left is, who finds it first, and will our theories finally be ready for it when they do? If this kind of deep dive into what NASA is actually discovering is something you want more of, make sure you're subscribed, because this is only the beginning of what 2026 has in store for space science. Drop a comment and tell me, out of everything we covered today, which discovery genuinely surprised you the most? I read every single one.